All right, so moving on. Limits. So sum of an infinite geometric series. So the series is already the sum of a sequence. The sum of the sum is saying basically the limit. So if I want to take the limit as n goes to infinity of some series, I hope you all thought that was funny and laughed. All right, so I'm going to take the limit. This, remember it's geometric series. This came from section 8.5. This is a formula you should know. I will not give it to you for the test. Okay? So this is for a geometric series. Yeah. So I can just replace the S sub n with this whole formula. Now if we look at it, the G sub 1, that's a number. When I know R, 1 minus R, that's a number. I can just pull both those numbers out as a coefficient from my limit, and now I'm stuck with the 1 minus R to the n inside. Okay? This n, this term depends on the n, so I need it in there. Now, if I don't know n, if I don't know R, I got nothing, I'm stuck. Woohoo! And typically you'd think, oh, R to infinity, that's going to be a huge number. But what if our R is a special range of numbers? What if it's not inclusive, it's in between -1 and +1? What numbers could be in there? Well, 0 is 1. 0 to the infinity power is nothing, okay? What if it's 1/2, or -1/2, or 1/3, or 1/15, or 15/16? All of those are fractions. They're less than a whole. They are fractions. So if you take a small number, less than 1, and you multiply it by itself, so if I take 1/2 times 1/2, I get a 1/4. That's way smaller than what it was originally. So if you take a fraction number and you multiply it by itself a bajillion times, because it's infinity, or you take 0. 0 is also in there. But if you take any of this range of R values in here, and then I get to the infinity power, it's always going to get closer to 0. And what's the limit of 1 minus 0? 1. So this whole limit is actually 1. If this is true, R has to be a fractional value, so it has to be between -1 and 1. It can be 0, but it never will be 0, because that's arithmetic, and a whole different story. But your R can't be 0 because you have to divide the two terms by each other. So in here, you have to have a fractional R. If that's true, this whole limit turns into 1, which means it kind of goes away, and then you're left with this. So if your R is a fraction, the limit of a series to infinity, of a geometric series, is equal to this value. This is awesome. Woohoo! Let's see it in action. So, example 2, there's a bunch in here. A is our first one, so we have 5/3, 5/9, 5/27, 5/81. Okay, this is our first series. Well, it's a sequence because it's just commas, but what if I put, oh, I guess that's a question. A, is it actually a convergent geometric series? Well, no, because it's not a series. But what if I changed A? Now it's a series. So now that it's a series, what's a way that I can write this out, first off? Well, I guess first, is it geometric? If I take 5/9 divided by 5/3, what do I get? 5/27 divided by 5/9. What do I get? 5/81 divided by 5/27. What do I get? Your common ratio in here is 1/3. So to write this as a geometric series now, I want S sub n is going to be, well, it's the summation. I want to sum each term. Each term starts at 1. I'm going to infinity. My first term is 5/3. My common ratio is 1/3. And my exponent will be n minus 1. Okay? So now that I've made this, it was already geometric, but I've now made it a series instead of a sequence. And I now have this. So this is my first term. They just use G because G for geometric. This is my R. Can you plug this in to this formula and figure out what this eventually would add up to? Pause it, figure it out. Come back and check when you're done. So I'm going to have the limit, as I'm going to infinity, of s sub n is going to equal 5/3 divided by 1 minus 1/3. 1 minus 1/3 is 2/3. So this is 5/3 multiplied by the reciprocal because my denominator is a fraction. So this turns into 2/3. So the reciprocal is 3/2. Remember, if you divide by a fraction, you multiply by the reciprocal. And 3's make 1, and I get 5/2. It should equal 5/2. So the answers are already in the book. At least they should be. I guess they're just blanks. Okay, we'll go over them. So on part B, I guess I turned A. I fixed it into part B because I made it a series. On C, is that geometric? It could be geometric, and my R value would be what? What is 160 divided by 640? So C, 160 divided by 640. That should be 1/4. So your R value is 1/4, which means that it is going to have a G1. So my first term is 640. My R value is 1/4. If R is less than 1, it converges. So I can use the 640 divided by 1/4. This is the limit to use proper terminology. The limit of s sub n is equal to this. This is 640 multiplied by the reciprocal. So it's 4/3, and that doesn't divide by 3. So that's a big number, and it's going to end up being 2,560 divided by 3. And then D is adding 2 each time. And so it's actually arithmetic. So if you add 2 each time, are you going to be converging? Are your numbers getting smaller that you're adding so at least they end so you can get an actual end number? No. So D will diverge. The limit will not exist. So for D, you could say diverge. If you also want to write it with the limit format, you can say D and E, or does not exist. That works too. All right, example 3. So repeating fractions. Remember what repeating fractions are? They are rational. They are actually series. So I can take the 39 and 4/10, because that part is solid. We know that part. The rest of it's what we're adding. We're adding to it the 0.065, where the 6 5s keep repeating. They turned this into a whole improper fraction, so 394/10. And then notice that this breaks down into 65 tenths, hundredths, thousandths. The next 2 places would also be 65, but this is tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So I'm adding 2 zeros onto it each time. So I know that I'm going to have 65 over, that's 5 zeros, so I need 7. 1, 2, 3, 4, 5, 6, 7. Put my commas in. So 10 million. And you get the idea. So I'm adding this one single number, plus this as the series. And, because this question's interesting. They're specific but not specific. In this, my common ratio is 2 place values, so it could be 1/100th, or you could write it as a decimal. Both would work. And they're using this to write it as a fraction. That's what they're doing. Okay. Because sometimes you work yourself backwards because you're like, oh yeah, and then you put it back in decimal form and you're like, oh, it's the same thing. Right, but then you did nothing. So you do have to go over this again. So if this section is getting smaller each time, so I have an R, so it is geometric, and this R is less than 1, this section itself will add up to 65 thousandths divided by 1 minus 100. I'm using fractions just because it makes simplifying simpler. And my calculator's dead and charging. So this will be 65 thousandths. This is 99 hundredths in the denominator as a fraction. So I'm multiplying by the reciprocal, which is 100 divided by 99. Those 2 zeros go away, so I'm going to end up with, oh, and that's 10. And 65 and 10 have 5 in common, so this will be 13, and that'll be a 2. Okay, so now I get 13 over 180 plus 18, so 198. So this section, they didn't simplify, and I don't know why they didn't simplify. Okay, but I like the simplified number. 13 out of 198. That's just these decimals, that 65 part. So I'm going to bring down my 394 tenths plus 13 198ths, and that will get you your big, huge fraction, and then you can make it a mixed number. This is them not simplifying it. Because, well, maybe I didn't. Because 65 should have 13 in it. Because 5 goes into 10, and that would be 1,000, and the 2 zeros would go away. I don't have my calculator with me because it's dead, so trust the book, but this is your final answer according to the book, and you get the idea. So I'll go back over it again. We took apart this part that's just static. It's not changing, it's not repeating. We made it one big number, one improper fraction. The repeating part is what we made the series, because this part is geometric, meaning it has a common ratio. If it's geometric and my common ratio is a fraction between -1 and 1, which this is, I know it's going to add up to, eventually this whole 0.65 will equal this summation. I know it'll equal the first term divided by 1 minus r. This is 99 hundredths, so I can take this numerator down here, multiply by the reciprocal, which is 199ths. I simplified, but apparently I did something interesting because I got this, and the book doesn't want to simplify. I don't know why, but this is the final answer your book gets, which doesn't have 5 go into it at all, so I don't know where 5 went. But, yeah. So, your homework is 1 through 18. Remember to skip number 5. Alrighty.